Don't get stuck on solving and graphing two-step inequalities. I went through and found my best examples of me showing how to solve and graph two-step inequalities inside the classroom, and I put them all together inside this video. So therefore, you get a wide variety of different types of solutions, as well as where students are going to get stuck when solving and graphing two-step inequalities. I hope you enjoy.
So when we're going to be solving this problem, guys, whenever you have an inequality, and I say solve and graph, what we want to do first, like I said, is don't worry about the inequality sign right now. We just want to treat these just like equations. So the first thing I'll do is I'll rewrite this as an equation. Okay? So once I have this now as an equation, now I can solve this using my two-step method. Now I know a lot of you are like, oh man, I forget the two-step method. How do we solve two-step methods? What do we do again? Remember, the whole purpose of solving is to get your variable by itself. So a lot of times I would say, circle your variable, what we call pinning it. Then look at what is happening to your variable. There's two numbers that are on the same side of v. I have a -5 and I have a -4. Then we need to determine what are those two numbers doing. Okay? So -5, since it's right next to the v, is multiplying. So we say -5 is multiplied by v. Then I have a -4. And what I can say is my 4 is being subtracted from my v. All right, since it's a -4, I'm taking 4 and subtracting it from v. All right, so therefore, now the next thing is, remember when we're doing our inverse operations, we had to remember, always do the inverse, always undo your addition and your subtraction first. So I look at this and say, well, since I'm subtracting a 4, the opposite of that would be to add 4. And the reason why I know that is correct, because remember, subtract 4, add 4 is going to cancel out to 0. And that's exactly what we want to get on the side of our variable, is to eliminate that number. And then I'm left with a -5v equals -25. So now I say, all right, -5 is being multiplied by v. To undo multiplication is to divide by -5. Therefore, v is equal to a +5. So now what we need to do is input back our symbol. Now remember, I told you guys, whenever you divide or multiply by a negative number, we have to do what with the sign? Rip it? Tip it?
Flip it.
Flip it. There you go. Always right. So therefore, instead of opening to the right, it opens now to the left.
Swag.
Okay? Then, like the first part of the worksheet, we just graph it. Wow. Okay, and I've already gone through plenty enough problems, guys, to do this. All I'm going to do is remember, make a point at 5. I know now, I've done enough of these problems that I know that since this is greater than, it's not greater than or equal to, it's going to be an open dot, right? Because if I put 5 is greater than 5, I know that's false, so therefore it's an open dot. Then it says v is all numbers greater than 5. Well, always look. Is it 3 greater than 5? No, those are all false statements, right? What about to the right? Are all the numbers to the right greater than 5?
Yes.
Yeah, 6, 7, 8, 9, 10. So I'm going to draw my line to the right. Okay? It's really helpful, guys, if you say it out loud. That will really help you do these problems. All right, so ladies and gentlemen, when you want to solve an inequality, we're going to solve this in graph. All right? To do this, the main important thing I want you to do is forget about the inequality sign. Just forget it exists right now, and let's just go back to solving equations. All right? Now, I know it's been a while since we learned how to solve two-step equations, but remember, two-step equations, we follow very, very important rules. The first thing to do is to always undo what's happening to your variable, right? So we need to figure out what's our variable. Well, our variable is p. Then I need to say, well, there's two numbers that are on the side of p, right? On this side of the equation side. We have a 2 and a 7. Now, I need to know what is my 2 and my 7 doing to my variable. What operations? It's either adding, subtracting, multiplying, or dividing, right? So I look at this, I say, well, 7 is adding to my variable, and the 2 is dividing by my variable, right? So we always, here's the first step, always undo addition and subtraction first. So So I need to undo addition of a positive 7. So to undo that, I'm going to subtract 7 on both sides of the equation symbol. So 7 minus 7 is 0. So now I'm left with p over 2 equals 3. So now I need to undo division by 2. So to undo division by 2, I need to multiply by 2. P equals 6. Okay? Now, the last thing you need to do is, once you have it done, you need to plug back in your original inequality sign. And remember, there was one step carry that we had is, remember, if you multiply or divide by a negative number, you had to flip the sign, right? So I go back and look through my steps. Did I multiply or divide by a negative number? No. So I'm just going to plug it back the way it was. So now, I do a number line. And what we're going to do is we're going to make a nice big dot at 6. Then I pick a point to the left, and I pick a point to the right. And then you plug those numbers into your inequality. So 1 less than or equal to 6, 6 less than or equal to 6, and 7 less than or equal to 6. Is 1 less than or equal to 6?
Yes.
Yes, that's true. So you shade in your little point, and you say true. Is 6 less than or equal to 6? Yes. Put a true, shade in your big point. Is 7 less than or equal to 6? False. Therefore, now we know that since it's true to the left of my point, all points are going to be true to the left. So we shade it to the left. Okay? And that's it. So when you have your two-step equation, just make sure you set it equal and just follow your two-step operations to solve for there. All right?
Yes.
Hello. So what I have here is 6 plus n divided by 4 is greater than negative 4. And so we're going to solve this by using our inverse operation. And this is a great problem because a lot of what I always say when using your inverse operations is always undo addition and subtraction first. So a lot of people say, well, I'm adding a 6, right? Because I can rewrite this as n plus 6 divided by 4. So you can easily say, oh, I'm adding 6, so I'm going to have to subtract 6. But the problem with that is, notice that n plus 6 divided by 4, that's the same thing as n over 4 plus 6 over 4. This 4 divides into both of these numbers. So if I'm going to add something, if I'm going to undo addition, I'm going to have to subtract 6 fourths. Now, you can do this. However, we don't really like subtracting. That's a multiplication. We don't really want to subtract a whole number minus a fraction because a lot of us have trouble with some fractions, and it's just a little bit extra work, right? So what we can do is, rather than having to subtract 6 fourths on both sides, let's just get rid of the fraction, right? I mean, why deal with all that extra work? So what we're going to do to get rid of the fraction is we're going to multiply by, so to get this fraction, this means we're dividing by 4, so we're going to multiply by 4. So by multiplying by 4, that divides out, because you're multiplying by 4 times a whole expression, so those divide out to 1, and then we'll get this, so we have n plus 6 is greater than negative 16. Now I don't have any fractions, and it's very easy for me to use my inverse operations. I subtract 6, n is greater than negative 22. So it means all numbers that are greater than negative 22. So I need to represent that now with the number line. All right, so I'm going to start at negative 22. And to the right are going to be my numbers that are greater than negative 22. And to the left will be numbers that are less than negative 22. And you can just think of, less than and greater than with negative numbers as far as money, right? If you have negative amount of money, that means you owe somebody money. So when you owe somebody more in monetary value, then you actually have less. So that's why these numbers are less than negative 22. So I always start at where my initial value is at negative 22. And we're gonna shade that in if our value equals negative 22. But when I say n is greater than negative 22, that does not mean n is equal to negative 22. So therefore, that's going to remain open. But then I say, what are the values? So n is greater than negative 2. What numbers are greater than negative 2? Well, that's going to be all these points that are to the right of my negative 22. So to represent them all, I'm going to have a nice little kind of shaded line. And I'm going to say, you know what? If I continue in this direction, I'm always going to have numbers that are greater than negative 22. And that's how you solve an inequality. Thanks. Okay, so on this case, we have negative 1/4 x minus 2 is greater than 8. Now, I had a lot of problems with students because right now your hour is up. Just saying, you guys, now we're running on your time. There's two different ways to deal with this, and we've been going over this over and over and over again for fractions. All right, so there's two separate ways to do this. The first way, ladies and gentlemen, is to get rid of the fraction. Why do we have a fraction here? The reason why we have a fraction, the reason why we have a fraction is because 4 does not evenly divide into 1. Or you could say -1. It doesn't really matter what you think of the negative. But 4 does not evenly divide into that, does it? Right? So that's why we have a fraction. So the easiest way to get rid of problems with fractions is to get rid of the fractions. So since we're taking 1, or -1, dividing it by 4, let's undo the dividing by 4, and let's just multiply everything by 4. So I'm dividing by 4. That's why I have a fraction. So let's apply distributive property and multiply everything by 4. 4 times negative 1/4 x minus where did I lose you? I'm multiplying 4 times every one of these terms. If, put that over 1. 4 over 1 times negative 4 over 1. The 4's divide out. Negative 1 divided by 1 is negative 1x minus negative 4 times negative 2 becomes a positive 8 greater than 32. Can you guys solve this equation now? No. Why not? OK. The next thing you guys can do is if there's only one fraction, just worry about the fraction when you have to. If I have negative 1/4 x minus 2 greater than 8, what is the first thing we need to do anyways? The first thing we need to do is always undo addition and subtraction. So we don't even need to worry about this fraction right now. Yep. Oh, wait, actually, never mind. I did make a mistake there. It's 4 times negative 2, right? So that should be a positive 4. Thank you. So now I have two separate equations. Here, all I did was add a 2 on both sides. All right? Now, how do we get rid of a fraction when it's just a fraction times a number? Well, you could divide. Now my variable x is being multiplied by negative 1/4. So to undo multiplication of a fraction, we multiply by the reciprocal. So I can multiply by a negative 4 over 1. I want to multiply by negative 4 over 1 because I want to make this a positive variable. And this is where the reason why in that problem I wanted you guys to always solve for the positive is because a lot of students, including myself, forget when you multiply or divide by a negative number, you have to flip the inequality symbol. So now this one becomes negative 40. OK? Huh? Yeah. Why would I go over it? Write it down. Flip the sign when you multiply or divide by a negative number when you're solving for a variable. Write it down. Here, let's go and do this. I add 8. Negative x is greater than 40. Divide by negative 1. Divide by negative 1, because we have to solve for x. X is less than negative 40. Notice, ladies and gentlemen, I solved it 2 different ways, and I still get the same answer. Right? So now we got to go and graph our solution. So again, just like I was going back, I'm leaving that. I'll just erase the problem. So now to graph the solution, what I would tell you guys to do is go ahead and find negative 40. OK? And then do the larger numbers to the right and the smaller numbers to the left. And you will have to create your own number lines. So now we get into this, and we make a dot at negative 40. And per our discussion in the last class period, is that open or is it closed? Open. It's open, because it's not true. And then you can do test points if you like. But since my variable is to the left of my inequality symbol,
you can see, one, the inequality symbol is telling us to go to the left. And let's just say it out loud. At what numbers x is less than negative 40? Is that numbers to the left or to the right? Left. Yeah, think about negative again as owing money. If you owe $43 compared to owing $37, do you owe less money the more negative it is? Do you have less money the more money you owe? Yeah. Yeah. So it goes to the left. Whew, so we got a two-step inequality, right? So for those of you that were not here, let's kind of go back through the steps so you can remember. Two-step inequalities, guys, we want to treat them just like we did equations. So first thing you can do is rewrite it as an equation. 5 plus n over 2 equals 8. The reason why this is helpful, because it's kind of psychological. We treat inequalities just like we do equations, but if we can rewrite it as an equation, it's just going to help us remember the steps to solve. So remember, the first thing we need to do is we need to undo what's happening to our variable, because our end goal is to get our variable by itself, right? We want to get n by itself. So I need to look at my two numbers on the side of my variable and determine what are they doing to my variable. Well, I have a 5 and a 2, right? I need to get rid of them. So I need to determine what is happening. Well, you can say the 2 is dividing into the n. So n, my variable, is being divided by 2. And then what is the 5 doing? Now the 5 is adding to the n. It's not adding because of this plus sign, but it's adding a rondé because it's positive in front. All right, that's a positive 5. That means I know that it's adding to my variable. So to undo a positive 5, I need to subtract 5. Therefore, that's now going to go to 1. Therefore, now I have n over 2 equals positive 3. Now I need to undo division by 2. To undo division, you multiply by 2. So therefore, I have n is equal to 6. Now, I plug back in my sign. And it's important when you're plugging back in your sign for you guys to remember, whenever you multiply or divide by a negative number, we flip the sign. So I go back to my work. Did I ever multiply or divide by a negative number? No. So therefore, I keep my sign the way it is. Then to graph, I'm just going to do a very simple line graph. We've already gone through the slow way of testing intervals. Here, I look at my point and I make a circle. Okay? And I notice that this is less than or this is a greater than symbol. Right? And remember, when it's less than or greater than, it's an open dot. Therefore, I don't fill this in. My point 6 is not equal at 6. So therefore, it's open. Then I just read it out loud. N is greater than 6. So that means which numbers are greater than 6? Numbers to the right, which would be 7, 8, 9, 10, or numbers to the left, which would be 5, 4, 3, 2, 1. So which numbers are greater? The ones to the right, right? So there you go. Got it? There you go. It's good. Huh? So once I have this now as an equation, now I can solve this using my two-step method. Now I know a lot of you are like, oh man, I forget the two-step method. How do we solve two-step methods? What do we do again? Remember, the whole purpose of solving is to get your variable by itself. So a lot of times I would say, circle your variable, what we call pinning it. Then look at what is happening to your variable. There's two numbers that are on the same side of v. I have a -5 and I have a -4. Then we need to determine what are those two numbers doing. Okay? So, -5, since it's right next to the v, is multiplying. So we say -5 is multiplied by v. Then I have a -4. And what I can say is my 4 is being subtracted from my v. All right, since it's a -4, I'm taking 4 and subtracting it from v. All right, so therefore, now the next thing is, remember when we're doing our inverse operations, we had to remember, always do the inverse, always undo your addition and your subtraction first. So I look at this and say, well, since I'm subtracting a 4, the opposite of that would be to add 4. And the reason why I know that is correct, because remember, subtract 4, add 4 is going to cancel out to 0. And that's exactly what we want to get on the side of our variable, is to eliminate that number. And then I'm left with a -5v equals -25. So now I say, all right, -5 is being multiplied by v. To undo multiplication is to divide by -5. Therefore, v is equal to a +5. So now what we need to do is input back our symbol. Now remember, I told you guys, whenever you divide or multiply by a negative number, we have to do what with the sign? Rip it? Tip it?
Flip it.
Flip it. There you go. Always forget. So therefore, instead of opening to the right, it opens now to the left.
Swag.
Okay? Then, like the first part of the worksheet, we just graph it. Okay? And I've already gone through plenty enough problems, guys, to do this. All I'm going to do is remember, make a point at 5. I know now, I've done enough of these problems, that I know that since this is greater than, it's not greater than or equal to, it's going to be an open dot, right? Because if I put 5 is greater than 5, I know that's false, so therefore it's an open dot. Then it says v is all numbers greater than 5. Well, always look. Is it 3 greater than 5? No, those are all false statements, right? What about to the right? Are all the numbers to the right greater than 5?
Yes.
Yeah, 6, 7, 8, 9, 10. So I'm going to draw my line to the right. Okay? It's really helpful, guys, if you say it out loud. That will really help you do these problems.